So guys, we'll be performing this practical today, which belongs to 2017 October November. We are selecting this because it has a different kind of titration, a different kind of acid, and obviously at the same time the qualitative analysis is also a little different. So let's begin. So guys, right now I'm pausing this past barrows, and present barrows is going to be teaching you the practical as another version in my parallel universe performs it. So what I'm doing right now, we have to understand the question first. LB1 is a solution made by dissolving an unknown mass of a mixture of ethane dioic acid, also known as oxalic acid, and sodium ethane dioate ions. You will carry out two titrations to find out the percentage by mass of ethane dioic acid in the mixture. In aqueous solution, both ethane dioic acid and sodium ethane dioate release all their ethane dioate ions. These ions react with manganate. So you have to understand that manganate is reacting with ethane dioate ions, which are coming from two sources. The acid, or I can write it the way the examiner has written it, the acid COOH twice, and also it is coming from the salt, which is NaCOO twice. So you will need more manganate is required. More manganate will be required because it is going to neutralize both the ions from both sources. FB1 is an aqueous solution of the mixture containing ethane dioic acid and sodium ethane dioate. FB2 is potassium manganate, and FB3 is 1.00 mole per dm cube sulfuric acid. So I am going to mute myself, and you can see what I'm doing on the other side. I'm just explaining in the beginning. The method is basically you fill the burette with FB2. FB2 was your manganate. So manganate goes into the burette. On the left hand side, you can see me actually taking the burette with the conical flask. And the reason is that I'm going to rinse the burette. So you can see how I am, twisting, or you can see I can make sure that the entire glass wall of the funnel is rinsed with the manganate, and my burette is also rinsed with it. I will be making my table on this side. So this is my rough titration table, or I can make it here only. You can see me rinsing on the other side. So while I am coming back from rinsing, you can see me complete the titration. So I'll pause myself. Here it will be final burette reading /cm cube, initial burette reading /cm cube, volume of FB2 used /cm cube. This is how you draw your table. I can extend it, and now I need to put in my values, so I remember my values, but we'll come back to it later. Now you can see that the nozzle of the burette is not rinsed, and you might have some air bubbles, so you just open the tap and make sure that it's transferred. It's an important part of the rinsing. You open the tap, and when you open the tap, obviously some of the fluid is going to pass through. When it passes through, this is exactly what you want, and if there's any air bubbles, they might be removed. I'm going to clamp my burette into the stand, and you can see the twisting of the knob. Make sure the jaws of the clamp crisscross into each other. I've shown you how to make sure. A lot of kids struggle with that because the jaws are टकराइंग on each other. You have to make sure that they're interlocking into each other. ठीक है जी. Now my burette was not straight exactly. That's me around Chris Evans, but meh. Moving on. So now I'm going to be taking the mixture which has ethanoic acid and ethane dioate ions both, and I will be kind of taking out a mixture using the pipette filler. So you know how to use the pipette filler. We have done that already. It's nothing new for us. So moving on, I'll fix it over here. Once done, I'm going to be taking some sample using the S wala knob. So I'll press it, it's going to create a suction, and some of the fluid is going to be transferred. So you can see this is how we are doing it. Meanwhile, I'll move ahead and I'll make the table for the second titration set. Again, the table is going to look very similar. Final burette reading slash cm cube, initial burette reading slash cm cube, volume of FB2 used. Whatever is going to be used comes from the burette, so always remember this fact, and then slash cm cube. Let me extend the table a little. This is going to be my first accurate titration, second accurate titration, and I'm just assuming I will be able to do it. You can see me tapping the pipette nozzle onto the base of the flask to remove everything. Now I'm going to be taking the measuring cylinder. They have mentioned this. You can see that. Use a measuring cylinder to add 30 cm cube of FB3. FB3 was sulfuric acid diluted. The reason was to provide aqueous medium. Not just aqueous medium, sorry, acidic medium. Now you can see I've done that. It's almost 30 cm cube. It has to be almost. Measuring cylinder is not accurate, and it is often for substances which are in excess. So you don't have to worry about the accuracy. That's totally okay. Now I will be doing the heating. So my heating is going on at the back. In the background you can see they want me to heat at approximately 70 degree. I am checking the temperature. Temperature has to be checked from the liquid, not the base. Do not touch the base of flask with the bulb of the thermometer. Otherwise your temperature will be recorded higher. So now when the temperature is ready, you have to make sure that the burette has been filled entirely. This is how you begin it. Obviously I'm just giving you a demo, so that's why you'll transfer drop by drop, and you can make sure you can see how the color will gradually change when you begin the titration. I am going to redo the titration obviously, but obviously this is the beginning. You can see the color has gone, which means that the reaction is going on. Let me just go a little aage. Yeah, so I am now actually doing my perfect titration. Now my titration is ready. I'm going a little more aage. Yeah, now I'm doing this titration. You can see the color is the color is going away. It's decolorized, which means that the substance is getting reduced. Let me remind you of the fact. Manganate gains 5 electrons and become Mn2 plus ions, which is a kind of reduction. And ethane dioate ions basically lose electrons and become carbon dioxide gas, which is a kind of oxidation. So I'm just going to move past it. You can see me adding some water in it just because thoda sa wall pe lag gaya tha, but that's okay. This should be your final color. This light pink should be your final color. Now let me write my values over here. For me, basically the values were 24.50, 0.00, 24.50. This was my value when I actually did it. And in like accurate titration, it was again 24.60, 0.00, 24.60. Let me extend the table a little more. You may have to perform more titrations, but that's totally okay. And then hypothetically, I'm just writing the second titration value. It is 24.65, 0.00, 24.65. So my value is going to be 24.60. 24.65 divided by 2 is equals to volume average, and it's going to be 24 point, what's in between, so that's 24.625 or 24.63. So moving on, this has been done. Now let's jump on to calculation. While this Barrows person is holding his burette and the flask, we'll move ahead. Before I jump to the next calculation, show you're working in approximate significant figures, so you have to be 3 to 4 significant figures. Calculate the number of moles of manganate. So moles of manganate is equals to the concentration times volume. The concentration, if I go back and see, it was 0.0200. 0.0200 times volume, which was 24.625 exponent minus 3. This was my volume. I'll do this on the calculator. I'm not flipping my screen because it might be a problem for me. So 0.020 times 24 exponent minus 3 basically times 24.625, 4.925 exponent minus 4. So 4.93 I can write instead of 4.925. I can make it 3 significant figures. Sorry, minus 4. Now calculate the total moles of ethane dioate ions present. So let's go back and see. According to the equation, 5 moles of ethane dioate ions react with double mole manganate. So based on the ratio, 5 moles of ethane dioate ions react with double mole manganate. So moles of ethane dioate ions is equals to, it's going to be 5 times more, by the way, 5 times more, right? But 2 times less. So it gives you an easy way of finding out. 5 times more means numerator mein 5 exponent minus 4 and then divide by 2. Don't forget to use calculator value. Quote this if you want, but use calculator wala value. So I'm doing the same thing. I'm going to multiply my value by 5 and then divide it by 2. So I get 1.23 exponent minus 3. 1.23 exponent minus 3. This is the mole. Now ethane dioic acid reacts with aqueous sodium hydroxide. Only acid, not the sodium salt. If you remember, we had both. So with sodium hydroxide, only the acid is reacting, not the other thingy. If I play the video again, you can see me now rinsing my other burette with the acid. I'm just, flipping it. Let me go aage thoda sa. Now this is an important thing. I want you to show that if there's any air bubbles in your burette, you open the nozzle and then you can see the air bubbles are passing through. And this is exactly what you do before you fill your burette. Don't fill your burette completely unless the air bubbles have been passed away, have been removed. Why passed away? Why would I say that? Now I'm going to clamp it again and I'm going to do the titration. Now I'm going to be adding indicator. You can see your examiner has asked you to add 10 drops indicator. Generally 3 to 4 drops are enough, but if you don't see the color change, add more. So I'm going to be adding indicator. I could not see the color change, that's why I'm adding more and more drops. So 10 drops is enough in this case. White tile is generally added to see the color change properly. Now you can see it is like in a light pink color. The same table will be drawn here also. I'm just going to copy my readings. You can see the color change happening on the left hand side. It changed. It's supposed to change to blue. So now you can see it is almost like in a range of yellow green ka shade hai. Now it is blue. Now this is a complete change and this is when you stop. You stop when there's a persistent change. So I'm going to copy this and I'm going to place it here. In a very similar way, I'm going to copy this whole thingy and I'm going to place it over here. So this is my first accurate titration. Second accurate for me, the rough was 22.10, 0.00, 22.10. So I quote it here. And for me, the others one 22.20, 0.00, 22 point, let's say 30, 20, sorry, 0.00. So 22.20, 22.30. My average volume is going to be 22.20 plus 22.30 divided by 2. That is my volume average. It has to be 2 decimal places. 2 decimal places. Do not compromise on that. So my value is going to be 22.20 and 30. So that's 25. So this is done with my titration. What am I doing? Oh, sorry, qualitative. No, I'm not here yet. Let's do some calculations. Calculate the number of moles of sodium hydroxide. So what do we need? We need the concentration. What's the concentration for sodium hydroxide? Have they mentioned? 0.04. And sodium hydroxide, by the way, this should be FB4 here and FB4 here. FB4 because you had your FB4 sodium hydroxide into the burette. So kitna value? 22.25 moles of sodium hydroxide is equals to 0.04 and volume was 22.25 exponent minus 3. Why am I adding exponent minus 3? To convert cm cube into dm cube. Don't forget this fact. Let's do it on calcu. I do not have my calcu. My phone just shut down. ठीक है, we can do it. We have a calcu here. 22.25 exponent minus 3 times 0.04. So that is 8.9 exponent minus 4. 8.90 exponent minus 4. This is here with me. Now, use your equation from D to calculate the number of moles of ethane dioic acid. Let's go back and see. They wanted us to balance this equation. You can see each acid molecule produces double hydrogen ions and the remaining ion would be COO with a 2 minus. This portion is separated and this portion is separated. So obviously in order to neutralize double mole protons, you need double mole alkali. And when double alkali and double proton mix together, they give you double acid. What are you left with? You are left with double sodium ions. So you're left with 2 sodium ions and you're left with COO 2 minus. This whole thing was COO double 2 minus. Like bracket ke bahar there was a 2, sorry. So your final answer has to be COO, then bracket has a 2 and then Na2. So this thing becomes COO Na twice. If you are confused with this, just a hint, they've already given you the formula of the salt. So you can put the formula and figure out the balancing. You can see the balancing shows you double mole alkali reacts with 1 mole acid. So between alkali and your acid, 2 reacts with 1. So mole of acid is equals to 8.90 exponent minus 4 divided by 2. So I'll go back to my calcu and I'll divide my answer by 2. So that's 4.45 exponent minus 4. That is 4.45 exponent minus 4